So when you take physics 1, right, you're gonna be seeing this one of the famous, like, the Newton's laws of gravitation. It's basically talking about, this formula, F equal to G time little m time uppercase M divided by R squared. That's basically talking about, the force, exerted between two objects with two different mass, or it could be the same mass, right? Is basically, formulated by the ratio with the distance squared between them. So as the distance of these two masses closer, and the force of attraction of each other will be stronger. And when the distance between these two masses are far away, then the force of attraction will be less. So that basically this ratio formula is talking about. Right? So what we are interested in now is, like, what if I take derivative of this equation respect to something? Right? So in this case, the only variable that we have is the distance, because the distance may be vary between two objects, right? Because the mass of the objects, once you start to climb, those are fixed already. And G is the gravitational constant, so that will be also fixed number. So the only variable that we have is the distance between these two objects. So what if I'm talking about, derivative of the functions, of this force function F respect to the distance? What is that derivative function going to look like? And what does that mean? Right? That's what we are interested in. And then also, like, how do we interpret it? Because we learn how to take derivatives. Now, when we talk about applications, we need to know how to interpret the derivative of the equations of the function. So for part A, if I take derivatives of this F equal to G little m big M divided by R squared, and respect to R on both sides of the equations. Okay? So derivative respect to R on both sides. So for this part, to make it easier for us to take derivatives, I'm going to rewrite it as R to the negative 2 power. And remember, G little m and big M, those are constant. So now when I take derivatives of this will become df over dr. That is equal to G little m big M, taking derivative of this r to the negative 2 power, which will give me negative 2 r to the negative 3 power. So let's give us df over dr. That is equal to negative 2 G little m big M divided by r to the third power. So that's the derivatives of it. Now, the question is, how do we interpret this? What does this mean? Right? So I sort of like explained it to you earlier that, this formula, what this formula is doing, right? So you have two objects with different mass, or it could be the same mass, but the force, right, between these two masses got stronger when the distance between these two masses are, like, close. If the force will be weaker between, attraction between these two masses when the distance between these two masses are, far apart. So when we talk about the derivative of this function, force functions with respect to the distance r, this is what we basically means. So the minus sign basically indicating, right, the force is going to be decreasing, right? So in this case, the minus sign indicate that the magnitude of the force exerted by body of mass m on the body of another, the other mass, the bigger one, right, m, is decreasing. And that's what it means. And also, why is that happening? We all know that the distance between these two bodies are also what? Increasing at the same time. Right? So also, distance between two bodies increases. I spelled it wrong. So that's what basically is talking about right there. Any questions before I move any further? All right. So the second part of this question is telling you that, suppose that it is known that the Earth's attractions, Earth attracts an objects with a force that decreasing at the rate of 2 Newton kilometer, 2 Newton per kilometer, when the distance is 20,000 kilometers. Now, how fast does the force is changing when the distance is only 10,000 kilometers apart? Okay. So this is a new unit that we haven't talked about it yet, right? I'm just gonna find out right here. This is called Newton, all right? N. So you can Newton units. You can look at it on Google. If you take physics already, you probably know this notations. Right? Here. So what is this basically talking about? Right? So it's telling you that the force decreases as the rate of what? 2 Newton per kilometer on when the distance is what? 20,000 kilometers apart. So that basically tells me that, f prime of 20,000, that is equal to negative 2 Newton per kilometer. That's how it's interpreted, right? Because that's talking about the rate of change on a force. At a particular distance, that's the rate of change, on a force part. So decreasing 2 Newton per. So now what we are interested in is finding out, how fast the force is changing. That means what is the rate of change on the force when the distance is only 10,000 kilometers. So to find this out, so first we need to start from what is a known value that we have, f prime of 20,000, that is equal to negative 2 Newton per kilometer. So what we can do is we can attack on the left-hand side. This is basically talking about, the derivative of the force function with respect to the distance and evaluating at 20,000. So that means we are evaluating this function right here at 20,000. And remember, G, M, and big M, those are the constant. So therefore, I will have negative 2 G, little m, big M, all over 20,000 to the third power. That must be equal to negative 2. So from here, if I divide both sides by negative 2 and multiply both sides by 20,000 to the third power, I will get the value of G, little m, and big M, which is equal to 20,000 to the third power. Now that we know this value, I can basically find out what is the f prime of 10,000 kilometer, right? What is the rate of change? What is the force changing? How fast the force is changing on the 10,000? So that's basically negative 2, right? Times with, and we know that G, little m, and big M is 20,000 to the third power. So that will be 20,000 to the third power, and divided by my R to the third power right here, which is going to be, in this case, my R is 10,000 to the third power. So if you simplify this, right, that will give you all the zero will cancel out. 2 to the third power is 8. 8 times negative 2 is negative 16 Newton per kilometer. So that's how fast, the force is changing when, two bodies are about 10,000 kilometers apart.